Okay, we are recording. At least I hope we are. Welcome to the evening of Python coding. Since it's coronavirus time, we will be meeting online and probably be meeting online for the next meetup as well. And maybe afterwards we'll see how things go. Hopefully we'll go back to regular meetups. Usually in this meetup we show a demo. This month, Eric Kelly is going to show us a demo of an NLP library called spaCy, and Eric is going to present himself and explain what spaCy is all about. So, to you, Eric.
All right, thank you. I am a data scientist. I co-founded a consulting company with a friend of mine. It's called Cardinal Innovations. The web address is here. If you have any questions for me, you can actually send a message to the contact form here, and it will go to me. I'm the only one that reads those messages. So feel free to send anything to that if you want to. So if you are planning on following along in real time, you can install spaCy very easily. If you go to this link and choose the options, and when you see this window, spaCy will give you the command line commands to type into your terminal or whatever, command line, and just download it and install it and get started. I am using a Conda environment, so I've made a Conda environment. I activated the environment, and then I installed spaCy and the English model into that environment using these commands. So that's how I got to this, to the point of using this this notebook.
You might want to give them a little bit more overview. What's the English environment?
The Conda environment? No,
the English.
No, English model.
Yeah.
So I installed spaCy and I installed an English model. That's this first line is to install spaCy, and the second one is to get an English model that goes with spaCy that we'll be using down below. So you'll hear more about that.
Explain again for those who don't understand what the English model is. Give us a little more overview, if you don't mind.
Well, in natural language processing, when we try to understand language, we use a model that is trained to help generate information about the words and the sentences and so on. So that's part of what you need to install. And there are other languages, as you can see. There's German, French, and so on. You can choose the option that is best for you. So spaCy is a Python library for natural language processing. We say NLP for short. And so what is this? What's natural language processing? Basically, this is a field where that brings together linguistics and computer science and artificial intelligence and a few other things, I'm sure. And it's a field that allows us to analyze text, analyze language. And if you think about the need for that, if we just have a piece of text, just a book or an article, a paragraph, and even if we want to do something using code to analyze that, it makes a lot of sense to take that text, that unstructured text, and create structure, to pull it apart and label the words and so on, and make a structured format that's suitable for analysis with code. So part of NLP is creating that structure for us. Other parts of NLP are about analyzing that text and finding information from it. We're trying to understand the meaning in the text. We're trying to find relationships between entities in the text and so on. Those entities could be people, businesses, lots of different things. So some examples are, we could summarize a book. We could find the subject of an article. We could extract specific entities or values from the text. And we can do that better when we have some understanding of the text rather than just writing some sort of search algorithm. So NLP can help us take advantage of the predictive power of of models that are trained to understand the different parts of the text. So spaCy in particular was designed to be fast and easy. There are plenty of other NLP tools. NLTK is another popular one. I haven't used it much, but it's very much in the research world. So you can go a lot deeper with NLTK in terms of analyzing text and developing tools to analyze text. spaCy is also very powerful, but it's not meant to be as flexible. The idea behind spaCy is just to give you a tool that's going to get you to an answer quickly. And so that's why I chose it. In my business, I'm doing work for clients, and so that requires me to get stuff done quickly. I really just need to get an answer and to move on. I used to be in research. I used to do research in the data science. In the geological sciences. And when I was doing that research, it was great to dig into a problem. But I don't have the luxury of time right now, and those sorts of answers aren't helpful to my business. So instead, I use spaCy, and it helps me get the job done. So let's start using spaCy as we learn the concepts. And really, it's very easy. These 3 steps will get us up and running. We're going to import the library, load that English model that we downloaded above, and create a document container that from some text that we'll use. And I'm just going to start with a simple sentence: "I love coffee." Very, very basic, and we'll feed that into the model. Let me catch up to this. All right. So this first line, just an import statement. We're importing the spaCy library. Down here, we're accessing the load method from the library, and we're telling it which model we want to use. The model I downloaded in the cell above is the English Core Web Small model. This is a pre-trained model that spaCy provides. There are medium and large sizes as well, and there are different languages. This small model is great for testing things and for demos like this. If you're doing something more extensive, you can download a larger model and use that instead. The size of the model has some correlation with the ability for it to predict the meaning of different parts of the text. So the bigger the model, the more it can handle in terms of diverse text and so on. But a model, it really is just it's a statistical tool. It's been trained to supply probability estimates for the different words or sentences or whatever in the text as to what their meaning might be. So that's basically what the model is giving to us. It's giving us this pre-trained predictor. So if we load that model and we call that instance NLP, then we've got our model, a model that we can use to start working on some text. So if we just pass "I love coffee" to the model, spaCy will output something called a doc container, a document container. So these 3 lines of code get us very far into the ability to make use of spaCy and to analyze text. So let's look a little bit about what is this document container and how does it relate to NLP concepts. One of the things it does, one of the things that spaCy does for us when it's making this container is that it tokenizes the text. So tokenization is basically just a way to define the different parts of the text. And so spaCy does that for us automatically. And I've pulled this quote from the Stanford site. They've got an online book on linguistics. And so what they say is, for tokenization, given a character sequence, and a defined document unit, like some text, tokenization is the task of chopping it up into pieces called tokens. And it's really, it's kind of that simple. We're just chopping things up into pieces. We're tokenizing the text. So that means we're creating words and sentences. We're defining instances of punctuation and so on. And so if we do that with the sentence, I love coffee. Sorry, I'm not, let me keep running these cells. So if we do that with I love coffee, we get something that looks like this illustration here. It's described by this illustration. This illustration I got from the spaCy documentation. So you're not going to see this normally, but this is a document container, an illustration of it. And really the container just holds these objects, these token objects. Each of these white boxes is a token object, and each token is based on a single word. So here's I, love, and coffee. So each of those words now has some labels on it as well. This first one is pronoun, then there's verb, and then there's noun. So already we can see that spaCy is breaking up the text and assigning some sort of information to each part of the text. So assigning that information is part of that structuring of the text so we can actually analyze the text. Ignore the arrows at the bottom of this illustration. They're from it's a larger illustration, and I cropped it so that those aren't important to what we're talking about. So in this sentence, we're trying to understand the language, right? So I love coffee. We're trying to understand what this means. And spaCy has made some predictions about the labels that are associated with each word. And this central word, love, is the verb. It's really where the action is in the sentence, right? This is the thing that's taking place. And from this token, we can see that there's an arrow going out to the first token, I, and it's labeled N subject, nominal subject. So what's the thing doing the action? Well, it's I. And what's the thing receiving the action? That's the direct object, coffee. So already we have some meaning to the sentence from this English model. It's predicted some labels that are helping us to understand the meaning of the words and how they relate to each other. So this really forms the foundation of NLP and what spaCy can do for us. From here, we can do a lot more. Some of these labels can be cryptic. So spaCy likes to be helpful. It likes to get to the point and help you do things. If you call spaCy.explain and add whatever that label is, or give it that label, it'll give you some explanation. Usually it's a very brief explanation or description. And so here's just spelling out nominal subject. So it's helping you understand what those labels are. So that's one of the little ways that spaCy tries to be helpful in each step of the process. So some of these other, so what are these labels? You're going to see, if you're working with NLP, you're going to see things like part of speech or POS down here. If you don't remember from your grammar lessons in school, part of speech is basically just a way these are categories of words. These are words that have similar uses in sentences. So we have a group called verbs. If the word has a similar use in a sentence, then it's basically a verb. Pronouns, nouns, and so on. Here's a whole list of part of speech words that are in English. Also, we have syntactic dependency, abbreviated DEP in spaCy. This gives the relationships between the tokens. So these are the ones that are labeled. These are the labels that are that are on the arrows in this diagram. So the nominal subject, that's a syntactic dependency. Coffee is the direct object, and they're connected by what we call the root, and that's the word love. So here, love is actually the root.
So Eric, does spaCy actually auto-assign those properties of pronoun, verb, noun, or is there a library that does that, or a sub-library?
spaCy is just doing it all behind the scenes. It's taking care of it for you. That's what the model is doing.
Gotcha.
Yeah, so if this small model is not working well, you can try a larger model, or you can even train the model to work better for you, which I'll show you at the bottom of the notebook. So this illustration is just from the documentation. So there's another way to visualize these relationships, and we do that using something called spaCy. So from the spaCy library, we can import spaCy, and then we can call spaCy render. And if we just pass our document container to it and give it the style DEP for dependency, it'll show us a diagram. That diagram is very similar to what we were just looking at. We've got the 3 tokens, I, love, and coffee, or well, 3 words, and they're labeled with the same labels we see, and we can see the dependencies with these arrows, and they're labeled with their syntactic dependencies. So as you're working with NLP, and if you're trying to visualize and try and understand the relationships it's deriving from the text using the model, you can visualize it with spaCy render. This render is what you use if you're in a notebook. If you're just on a command line, you're going to want to use serve instead. That will open a web browser page and display the image in the browser page for you. So once again, spaCy likes to be helpful. If you do something wrong, you might see an error message, and spaCy likes to give you more information in that error message than you would normally expect. So this sentence doesn't actually have what we classify as entities. Entities are things like companies, or a person's name, or an amount of money. Those are things that it defines as entities. So we don't have a person's name in here, we just have a pronoun I. So there are no entities here. So if I try to plot something with the style of entity, I get an error message that is a little bit more helpful than your average error message. So it says, no entities to visualize found in doc object. If this is surprising to you, make sure the doc was processed using a model that supports named entity recognition, and check the docs.ent property manually if necessary. So it's giving us a more or less plain English description of what might be wrong, and it's giving us 2 options of what might be wrong. So again, spaCy likes to be helpful. I know that we're using a model that supports named entity recognition, but it says check the doc.ents property. So we can do that. This is we're just accessing the object in the container, or the attribute of the container, or I guess it's an object, ents for entities. And if we look in there, we can see there's just nothing in there. There's nothing in there because we have no entities in this simple sentence. So let's try a sentence that actually does contain entities. So I'm gonna run the model with this other sentence and replace our document container with this one. And I'll go ahead and plot the dependencies. And now it's much more extensive. It's a longer sentence, and we have more to describe and more relationships between them. So this is, Apple is looking at buying UK startup for $1 billion. So Apple, proper noun. I guess that's auxiliary. Looking is a verb. Notice that I'm not the expert on English grammar terminology and whatnot, but to me this looks like a root of a portion of a sentence because we have these arrows emanating from it. So it's like a focal point. This has dependencies around it that the arrows are pointing toward. So Apple's looking at buying UK startup, and then for some money. Let's see. So there's the subject, and we can see the verb is this root with lots of arrows coming out of it. And then there's another verb, basically, because it's looking at buying. And so that creates another focal point. And those arrows are going out to basically a compound, a UK startup. So, I mean, I suppose we could talk a lot about this, but what I'm trying to give you an example of is how the model and spaCy are able to estimate or predict the relationships even in more complex language. So even with this sort of dual verb thing, it's tracing those relationships down the line. It's tracing them out for us.
Is there a way to see that in like a tree structure? Like, is there a spaCy, like a way to map that in a tree structure? Because I know that that's what a lot of linguists actually do, is they map that down into like a kind of a tree or something like that. This is kind of linear, but I was curious about that.
I imagine so. I don't know offhand. These are the kind of diagrams I look at, and frankly, I don't look at them too much. I'll look at them when I'm trying to analyze a problem, and it's usually a single sentence or so.
I'll argue that this is a graph. It's already a graph because you can see all of those. It's just where you put the nodes doesn't matter. They put the nodes in the order of the sentence. So it is a graph. It's kind of like a tree structure. So this is what I'll argue. It just looks differently than probably what you're used to. And someone said that is a helping verb. Well, I guess it's auxiliary here. But and
right.
I will add one more note. You probably want to emphasize this later, but NLP is not perfect. It's just good enough.
Right, and these are models. And spaCy has their default models. If you don't like them, you can change them. There are ways of labeling words that vary depending on which library you're using and so on. So yeah, some of it might look a little different and might not quite fit what you're expecting, but this is the way spaCy does it. And in terms of the tree, my understanding from the question was that maybe it was more like sort of like an outline type tree or something a little more compact, or displayed in a different way. So that's how I understood it. And I think there probably is, but I don't know of it offhand. So anyway, we're seeing this form of the text for entities. For dependencies. But we can also look at this one as in terms of entities, because we have some entities here. Apple is a company, that's an entity. UK, I think that's considered a geopolitical entity. Anyway, if I run this guy, we get another view of the sentence in terms of entities. So Apple is labeled with ORG, organization. UK, geopolitical entity, and then 1 billion is labeled as money. So it's a simple example with 3 entities in it, and it gives you a nice visual to scan over the text and see how the model's doing. And I'll use this again down below, and you'll see a little bit more of the use of it when trying to understand entity relationships. And actually, that's something I should have mentioned earlier. One of the things I do, or the thing I do the most with spaCy, is entity relationships. So I'll give you an example below that gets into that just a little bit more. So those are some visuals. We can access different parts of we can access the different attributes and so on just by digging into the document container. So here are just a few examples. One thing I'm pointing out is that you can specify an index for the document container to get the first token in the index. And if we print that, it gives us text, but there's also this text attribute. You can put that on there too. Both of them do the same thing. So when we're looking at the text, the first token is Apple. So that's at index 0. So it printed out the text for Apple. Or I can call text directly. You can also print each of the tokens in a loop. So these are all the tokens that it has defined. Notice that when it's labeling here, it lumped together the $, the 1, and the billion word. But out here, they're actually considered individual tokens, the $, the 1, and the billion. We can print out more attributes. So here is part of speech, and here's dependency. So I can just print that guy. Can be a little difficult to look at, right? Apple, proper noun, nominal subject, and so on. Let me do another printout with just some more formatting just to make it a little easier to see. And I'm going to add some more attributes. So here we've got all of the tokens from the text, all of their parts of speech that are labeled by spaCy. And I also use the spaCy.explain method to print out the descriptions for each of those. And then I did the same thing for dependency and
Eric, can I ask you a question?
Sure.
Did you preload all these scripts, or are these standard scripts? Is this customized for your purposes?
Yeah, I wrote these out. Yeah, these are mine. There's some code below that I pulled from the spaCy website, but otherwise this stuff's mine.
Okay.
Yeah. So this is just a method for formatting. When you're printing, you put the F and you've got an apostrophe with stuff in it. Inside these braces, we can put something. Normally we have a variable, but I just typed the word text in there and I told it to be left justified by 10 characters. So little tricks like that in Python that can make printing a little bit nicer.
Eric, I mean, before you continue, some people are asking also things in the chat.
Okay.
Feel free, unless you cannot ask a question for some reason, you have some technical problem, feel free to go ahead, unmute yourself and ask a question. If you're not asking a question, I would ask you to mute yourself. This way we won't have all sorts of like funny noises in the recording. Again, anyone can jump in and ask a question. If you cannot, write in the chat, please ask for me and then I'll ask it for you. Okay, sorry, Eric.
That's okay. Yeah, no, I had the chat minimized. So I see a question from John about whether the text, it handles just static text or could it handle a data stream. I don't know. I would imagine there's a way to handle a data stream very nicely, but in the end, really, when I've handled any kind of streaming data, usually it comes down to a matter of taking a chunk of the data, processing it, taking the next chunk of the data, processing it. And so when you process that chunk, it's effectively a static thing for that bit of processing. But someone else may know better than me about spaCy's ability to take something like a Twitter feed. I mean, a Twitter feed to me would be like, I assume that you'd be getting chunks of text from Twitter, right? Each of the tweets would come out and you could just grab those, process them. So that sounds like part of a bigger pipeline where you're handling the dynamic nature of the text coming in, that stream coming in, and then you're handing it to spaCy, but spaCy doesn't know the difference. It's just processing a chunk of text. But again, I'm mostly guessing on that one. Okay, so yeah, this is just, I went to the effort of printing it more nicely so we could actually look at the descriptions here more easily. Otherwise, you get a mess like this thing.
You can hide your chat. I'll handle it for you.
Okay. So what else did I print out? I printed out lemma and isStop. So lemma, that is the root or base of a group of words. So here's an example. B is the base of the words am, are, and is. It's the idea of distilling down the word into its root form or its base form. And I honestly, I don't do much with lemmas. spaCy handles things, and whatever its defaults are, oftentimes I just leave them and my results turn out great, so I have no reason to change them. But my intuition from other types of modeling is that the lemmatization of word, oh, sorry, let me give you some examples from here. So here's B. So that's the root of is. And the next line, looking, the root of that would be look, and so on. I think there's just buying and buy. Yeah. So it's trying to reduce it to the root form. So again, just my intuition from data science, other modeling that I've done. Oftentimes you want to avoid getting too specific with the characterization of your data. You want to generalize a little bit more. So if you can reduce the number of words you're trying to model specifically, then your model might generalize a bit better. Also, you're going to be able to reduce a sentence, for example, down to a more pure form of the sentence, if you will, and you're dealing with representations of those words that are single values instead of, say, 6 values for all the different tenses of that word. So the calculations would get smaller as well. That's an issue with NLP. NLP is very computation intensive. So my intuition on lemmas is that it helps with a couple of those things. And I'm sure there's more. So anyone who knows more about lemmas, I'm happy to if you want to speak up. But I haven't had to modify them in spaCy. spaCy's handling all that stuff nicely for the work I'm doing. The other thing here is stop words. So a stop word those are the common words that are sometimes removed from text before some sort of analysis. Those are things like the word the, that one is often removed. Some of these words like at, for example, that might be, yeah, actually that's labeled as a stop word. So what do we have? We have is and at and for. So based on what spaCy is loaded with, the defaults in spaCy, it's labeling these as stop words. And so it removes those. It either removes them from the text when it's analyzing, or it's reducing the influence of those words while it's analyzing. And I actually looked for that, and I couldn't find an answer. But there's debate about whether using stop words to remove or reduce the text is helpful. That's a debate. It depends on what you're doing. If you're working on something that deals with phrases, you probably want prepositions in there. So they may be helpful, they may not be. My impression, I'm not quite sure, but my impression is that spaCy is reducing the influence of those words when it's making predictions about the meaning of the words. I don't think it's removing them entirely. But I gave you a few links here if you wanted to look into those a bit more. Again, it depends on what you're modeling as to whether or not you actually want to remove them or add to the stop words or what. And so here, if I run this guy, you can see the stop words that spaCy actually has in its default list, or for this particular model. This is the small English model. So this is just what spaCy has in there. If the word is in there, it's labeled as a stop word. And you can actually edit this set of words. You can add or remove words if you want to. But again, that's a little bit more advanced than what we're doing tonight. I just want you to know that I wanted you to be aware of it in case that's an issue farther down the line. So if you do modify your model, you're going to want to save and reload it. So spaCy makes it easy to save the model. You can just choose a directory. I think the directory needs to exist in order, so you have to make that directory probably. But otherwise, all you're doing is taking your model instance and using this toDisk method, passing that directory to it, and it will save all the files necessary in a folder with that name. To load it, you simply point to that same directory and use the same load command. It's very, very easy. So I'd like to pull up an article, just a random article I found online, and I'm going to load, and we're just going to do a quick analysis of it, and I'm going to show you easy way to do a quick training on the model to improve it. So I'm using the Core Web Large English model. I think the small model would actually work pretty well, but I loaded this one. I'm going to load this one just in case. And the text is in the repo. It's just called Yellow because it's about this company called Yellow Messenger. This is just code to read that file into a text object. So I can do that, and I don't know if okay. I thought I had a printout, so I guess not. So this is just text. So we can just print out the text. This is the text of the article, right? Global demand for conversational AI system, and so on and so forth. So that's the raw text from that file. We can load that text into, or we can create the large spaCy English model and call it NLP again. Takes a few more seconds to do that. And then we'll load the text into that model. It will create a document container for it, and I'm just going to print the doc. That'll print the text from the article. Notice that the doc is actually making use of the, well, I'm using the print command too. It's making uses of the line breaks, so the article is a little easier to read here. And it's basically broken out by paragraphs because there are line, new line characters defining those paragraphs. But otherwise, they're mostly single sentence paragraphs. This one has 2 sentences. You can see the period right there. Anyway, this is what the article looks like. Basically, it's about this company, Yellow Messenger, and it's got several entities in there and so on. So we can analyze this and have a closer look at it. Also, just for some utilities, if you want to look at each individual sentence, you can print sentences. So from the container, you can access the sense attribute that holds all of the sentences. And you can just print each sentence. Looks like this. Very similar to above, but it's printing individual sentences, not paragraphs. Anyway, that shows how you can access different things in the document container. I'm showing you these things because if you want to work on a specific sentence, there are ways to access those specific sentences. You can also pass, so that's,
Are there any specific gotchas when in processing for sentences, things that it doesn't handle well?
Yeah, good question. This is pretty easy text. A lot of the text I work on are legal documents, and oftentimes they, well, most of them are basically these are PDFs. They're paper documents that were scanned into PDFs, and so what I'm reading really is an image, and then I have to extract the text from those images, and so the text I get back can be messy. I get really accurate text, but sometimes instead of a period character or punctuation mark, it's maybe the letter I, for example. So it might mistake these 2 sentences in that case for one long sentence. So that is one pitfall of processing text in NLP. These sentence delimiters may not come out right in whatever text you're working with. If the text is otherwise formatted well, then it usually comes out great. I don't have many problems with it, but unfortunately, I don't work with such clean text most of the time. So I have pre-processing routines that go through. So after I've stripped the text out of one of these documents, my code will go through and try to clean up any of those issues. It'll look for these I's that are at the end of a sentence. So like in this example, the word vast makes sense, but vast with an I at the end does not make sense. So there are libraries for spell checking and other kinds of things that you can use to build tools that will help identify these guys and fix them. But it depends on what you're working on. There's certain characters that don't work well from legal documents, and so I have routines that clean up those specific characters. Otherwise, things turn out pretty well.
Thanks.
Yep. Thanks for the question. So
Another
we
question?
can access individual sentences, but notice that I'm wrapping this guy in, I'm making it a list.
So I think you wanted another question.
Yes,
go
if
ahead.
possible. Yes, if possible. So can you provide a larger view? If you're working with legal documents, I'm assuming this is in some form of discovery where you're looking for particular items within a vast pile of documents. Is that how you're using spaCy?
It's more about yeah, I mean, right, without giving away client confidentiality, right? So it's basically finding entities, and oftentimes these are people, but they could be companies. And in some cases, I'm dealing with property. So I'm finding who owns what property. And there's also occurrences of percentages of ownership. So I'm tracing out who owns what property and what percentage. And there can also be a series of events or like a story that's written into the document. I mean, you can think of a contract. It's describing who owns what, but it might also describe this person sold this much to this person and so on. So I'm pulling out that information and basically out the story, who owns what today. So
Okay.
spaCy
So,
gets me the raw information, and after that, I can use some other code to try and put it together. But understanding those relationships are key, because if I just searched a document for words that look like people's names, I won't know what those names relate to. I won't know if those names have anything to do with the property. But with NLP, I'm getting the relationships between these entities, and it's helping me to understand that that person does have some sort of ownership of the property that's being described.
thank you. That's helpful.
Sure, yeah.
Hi. I have a quick question. Would you mind explaining how you are extracting text from these images? Because I'm looking to do something similar.
That's
Or is that too big a question?
it can be difficult, but it's actually getting easier. Basically, I'm using a couple of libraries. OpenCV is a library that helps to process images, and you can use it to clean up an image, sort of like you would do with Photoshop. You can sharpen and so on. I use that combined with the Google library Tesseract, if I'm pronouncing that correctly, Tesseract, Tesseract. And that's just a fantastic library for extracting text from images. Okay. And the version they have now is working really well. And some of the fixes I had to do in the past, I no longer have to do. So if you have Tesseract and you have OpenCV, you can do a lot with moving image data into text data. But otherwise, it's a long story.
All right, thank you.
Sure. All right, so we can access all these sentences, but this document container is actually, or actually, I guess it's sense. I'm not quite yeah. Sense, I guess, is a generator object. Because of that, I need to turn this into I can turn this into a list. Once I make it a list, I can access individual sentences with their indices. So let me just print this guy. So after I've turned that into a list, the first one is the first sentence. And then the first index of that first sentence is the first token. And once I get to that point, I can start accessing the attributes of the tokens. So there's part of speech as adjective, I assume. So this, again, other ways you can access information inside the document container. So when we look at the text like this, without reading every word in the document, it's kind of hard to know what's in here. But because I'm looking for entities, I can use spaCy and just make an image of this. So now you can see highlighted entities that it has predicted. There's a research or an advisory firm called Gartner. It's an organization, that's correct. The number, or the word 3 is a cardinal number. India is a geopolitical entity. It's calling Yellow Messenger a product, which actually is incorrect. Yellow Messenger is an organization, it's a company. So that's where the model has failed. It's got some money. These are all color coordinated, right? So all the orgs are these light blue colors. Products are green. Notice down here, we've got Facebook Messenger. It's calling that an org, a company. And that's actually incorrect too. Facebook Messenger is a product of Facebook. Facebook is the company, not Facebook Messenger. So the model did really well. There's a lot of good predictions here. It's predicting languages. These are all languages in this kind of pinkish color. I don't remember what NORP is. Down here, it's calling yellow messenger a person. So there's another false positive, right? That's an incorrect prediction of what yellow messenger is. Here's a person, and that's a correct prediction. So this is the large English model from spaCy, and it did pretty well, but it could use some improvement. As I've, well, let's look at some entity descriptions. So this is a formatted way to just print out some entity descriptions. So instead of that visual view, you can also list things out, and I printed those descriptions to get a better sense of what these are. So you've seen the label org. Those are companies, agencies, institutions, and so on. We've also seen product. These are objects, vehicles, and foods, and other things. These are not services specifically. So you can see how they're being defined and get a better sense by looking at the descriptions of these labels. So yellow messenger was labeled as a product here, and that's incorrect. It'd be nice to correct that, and I think that's what we're doing next. Yeah. Are there any questions at the moment? I'm going to go into kind of another section here. And we're almost done. No? Okay. So we can improve the model. There are many options. This is modeling. This is data science. There are many ways to improve a model. One way we can do that is to well, let me stick to the text here. So we've got several options for improving the model. What we're doing right now is we're starting with we have a pre-trained model. That's what we've loaded. That's what we got from spaCy. It's a model that's capable of doing a lot. It's generalized for the English language. If we want to make it more specific to whatever problem we're working on, we can train on top of that model. We can improve that model by continuing to train with new data specific to our project. This will basically push so the model has weights in it, and those weights are helping to guide the output towards one sort of prediction or another. And if we train the model a little bit more with some more examples, we're going to move those weights just a little bit and try and nudge it in the direction that's helpful to us, to try and correct those errors. Other things we could do, like we said before, maybe lemmatization is causing problems. Maybe using stop words is causing problems. I don't know, but there are lots of options. And generally, I don't need to mess with those other things. Instead, I like to use training data and give it some examples so it can learn a little bit better how to predict the text. Once again, spaCy likes to be helpful. These are links to code snippets and other code that you can just take from the spaCy website. That's why they're there. They put them out there so you can use them. And so what I did is I grabbed one of these guys and I pulled it into this cell. I modified it only slightly. I got rid of some stuff that we don't need just so we could run it in this notebook. Otherwise, I could have pasted that. I could have pasted the code directly into a file and I could run it immediately. That's how complete the code is for these examples that spaCy gives us in these links. So I'm not going to go through all of this, but obviously we were doing some importing here. There's some other libraries that are going to be useful down below. And then the key here is that we're going to make, or I've already made some new training data. These are only 3 examples, but let me show you what we have here. So this is a list, right? We've got these square brackets. Inside that list, we have 3 tuples. Each one of these is a tuple. Inside each tuple, it starts with raw text, an example of some text. I took these from the article. I think I modified them slightly. It'd be nice to, so it's usually good to use examples that are not directly from the text you're trying to analyze, but in this case, using stuff that's very close to it is fine, just because this is a demo. And so in the second part of the tuple, this is a dictionary, and that dictionary holds, it's a key with a list as a value. These are the entities that the model will want to know about. And inside that list, we've got more tuples. Each tuple has the start and end index of something that should be labeled. So from index 0 to index 16, or the index just before that, it should be an organization. That means everything that I've highlighted right here is represented by 0 to 16, and that should be labeled org. Okay, so this is a known value. This is what we refer to when we talk about supervised learning. We're giving the model examples of labeled data to learn from. I've given another one from 33 to 38. That's a geopolitical entity. That's India. Those indices right there. I did the same thing for these two sentences. So what I'm trying to do is fix yellow messenger. I want it to recognize yellow messenger when it analyzes the text. So I've got 3 examples that are going to help that. I've got 2 with yellow messenger in it. I chose to put one at the front of the sentence, but I don't want to have them always at the front of the sentence. So I put one in the middle of the sentence. I wanted to diversify the data. Again, those are just the indices and label. And I also wanted to fix Facebook. So I made up a sentence. I made up this sentence, and I made sure that Facebook was by itself as an org, right, as a company, to differentiate it from Facebook Messenger, which is a product. So I've got org labeled and I've got product labeled. So we're just taking that large English model. We're going to give it 3 examples. It's going to look at these examples many times, and it's going to push the weights of the model in the direction that will help it identify yellow messenger and Facebook more correctly. And so again, I took this code just from the spaCy web page. It defines a function, and we're just passing into it a model. That's our English model. Output directory, where do we want to save the model? And the number of iterations to go through when we're training. And if you're familiar with training in machine learning, this is the equivalent of an epoch. So these are epochs, maybe 100 loops around the training code. So a lot of this we don't have to worry about. It's just sort of, it's spaCy setting things up, taking care of things for us. We don't need to worry about that here. The main part of this code that's important to us is in here. So in this part of the code, basically, we're looping over the training data, or we're looking at the training data many times, in this case 100 times, shuffling the data. So this is the number of iterations. We're looping over the data 100 times. Each time we're going to shuffle those 3 examples. Down here, we're making batches of data. We don't need to go into what a mini batch is, but we're making batches of data that is basically sampling different parts of the data to do some training on, and then with those results, it will improve the model. But without going into that too much, instead, we can see that for each of those batches that it makes, it's pulling out the text and those labels, those annotations that I made in the training data from here. So by the time it gets down here, really what it's doing is pulling this out as text, and then it's pulling this out as the labels, those annotations. That's what these two guys are. And it's handing those over to the model with an update method. That method knows to take this example data, make a prediction, and then compare it to the annotations of the known values that it should be getting. If there's any difference between what it predicts and those known values, that's what we call loss. That's the difference between the model's prediction and the actual results. It uses those losses to determine how to change the model. So when the model predicts something that's very far from the actual value, it tries to move the model values in a direction that's closer so that we close the gap between the prediction and the actual values. We want those predictions to be exactly the same as those actual values. So it's going to push in that direction when it updates. So it goes through this many times and tries to get the model better suited to handle the examples we gave it. We don't want to go too far because we could train the model away from the stuff it already knows. We're basically, the model's learning, and if we go too far, we can basically ruin some of the stuff it's learned before. But going over it 100 times with just 3 examples, that's pretty small. So it's just a nudge for this model, really. And then down here, it's going to print out some results and save the model. So there's not a whole lot to discuss on that part. And then all I'm doing to call that function, this whole thing up above that's the function, is defining a model directory. And that's just inside my repo. I just gave it a name. And this code, it will actually make the directory if it's not there already. And then I pass to this function the name of the model, the directory, number of iterations. So if I run this, it'll go pretty quick. Well, I mean, I'm on a pretty powerful machine, but it'll go pretty quickly. I think it's running, or maybe it's not. Or maybe did I run? Yeah. Okay, so that's running. There it goes. It's printing out. It's printing out the losses, and the losses are the difference between the prediction and the actual value. So we want the losses to be smaller, and here they're about 7, 6, 10, and so on. We can see that those losses get smaller. That means it's learning. It's learning to recognize those names, Yellow Messenger and Facebook and so on. Then it prints out those results, and they're kind of messy to look at, but basically it's saying, hey, I found this word Facebook and I called it an org. And yes, that's correct. We wanted it to do that. Same with Facebook Messenger. Now it's calling it a product. That's great. It did other things that we wanted to do. It's a little easier to just look at the spaCy rendering of the text. So I'm just going to go ahead and load the text again, load up the NLP model from the directory that was just written, pass the text to the model, make the document container, and then render that text for entities, just so we can see how it turned out. Okay. So earlier we saw that Yellow Messenger was a product, but now it's coming out as an organization, which is correct. All these blue ones are organizations. So there's Yellow Messenger again. There it is again. It's a company. Same with this one. So that's doing that correctly. And then the other one was Facebook. Now Facebook Messenger is a product. So it's correctly predicting Facebook Messenger and Yellow Messenger just from that small amount of training. So that was really easy. There's some more examples. It still has this person correct. And I think all the others are correct. I don't think I've spotted one that's incorrect. So at this point, the model is working really well for this particular article. It'll probably keep working well for other articles. It's just that we've given it new information. It probably never heard of Yellow Messenger before, but now we've told it Yellow Messenger is a company. So when you come across Yellow Messenger, please label it as a company. So that's an example of how you can train a model for whatever project you're working on. Generating data is more difficult. So up here, I just put in 3 examples. It's these 3. There are programs that are helpful in creating data. They can help you run through data very quickly. There are other ways to produce data that maybe we don't have time to go into unless people have specific questions. But even just handing it a few examples was pretty easy. So in some cases, if your project's relatively small and the examples are fairly unique, just a few training examples might be enough to help you. If it's more extensive than that, then you might have to get more data and do a lot more data generation so that you can train more thoroughly. So, and so that's about it. That's an example of named entity recognition with spaCy and some code showing you how to do a little training to improve the model.
Well, thank you very much. If anyone has questions, now's the time to ask them. After that, we'll probably finish the video. You can also ask questions afterwards, but if you want those recorded and the answers, usually the answers to the questions are much more informative than some of the talks. But go ahead, and you asked a few, but go ahead and ask a few more.
I have a question.
Go ahead.
Yeah, so in the description that you gave earlier of a legal process, taking it away from your particular application, if we were looking at, say, development of a product or something that occurs over time, I'm assuming that the documents and the files that you're looking at have to be arranged in a chronological order to make them useful. Is that correct?
Not necessarily. What I'm doing is extracting information from the documents, and then I put things together after that with my code. And the documents are all dated. So I have the date of the document, and I have, and oftentimes the sentences contain dates that describe some sort of transaction.
Thank you.
Sure.
I have a question. Can you tell us about other things that spaCy can do that you haven't talked about? Just give us a little bit more.
I mean, I guess it's all the usual NLP things. So just the examples I gave before. So let's say you have the text of a book or the text of a report. Actually, there's an example of, so a lot of companies have old reports that are scanned as PDFs, and if you can pull the text out of there and you want to have a description of what's in that report, let's say it's a 100-page report, you might be able to train an NLP model to read each report and give you a summary. So there are ways of outputting an English summary, like a full paragraph or several paragraphs of text to describe that document. I am not doing that kind of modeling, so I can't tell you much more about it. That's going to be a harder task than what I've shown you here. But you're basically training a model to not only understand the text, but to output text that can be read by a human and understood. So that's a very powerful thing you can do for a company. I have a friend who does that. He does that stuff night and day. I think he's kind of sick of it, but it's definitely a sought after skill. Other things, I mean, basically anything you can think of where you need to understand something about text. Like the example earlier with Twitter, if you're trying to keep an eye on things that are happening on Twitter, some sort of, maybe you want to know what a certain group is upset about or happy about. NLP can help you understand the tone of the text. There are ways to, I mean, that's part of the understanding that it's generating. I mean, lots of examples, I suppose. Just anything you can think of, really. There are methods in NLP to do that.
Yeah, this is good enough. So you're saying that it can generate summaries. spaCy can generate summaries for you.
Yeah, I mean, I have not done that, but it's well, I mean, I've played with it, but I wouldn't say I've become an expert on that particular problem. But yeah, that's part of what people are doing with spaCy and NLTK and so on.
Okay. One more question. You gave several more examples of libraries. Can you give a little bit of direction of what the difference between spaCy and the other libraries are? Like why would you use the others, if at all, and when do they interact? Just a few words, nothing very extensive.
Yeah, I suppose I don't know much about the other libraries except for NLTK. NLTK is it's a natural language toolkit. I think it's one of the original NLP libraries for Python. And from what I know, it's being used much more in the research part of natural language processing. And I think it's much more exposed as a library. You can dig into the methods, and I think it probably has many more options for how you can train a model and how you can apply that model. It's really a tool for developing algorithms for NLP, I think primarily. That being said, it's still used in production. Companies still use it, but you really have to be, I think, more of an expert with NLP and NLTK to get up and running with that one. spaCy is different in that it's meant to be sort of plug and play. You just get up and running and run. I mean, this window right here, this text does a huge amount for us, and it's just how many lines? It's 5 lines of code. That's the fast and easy way with spaCy. It's not meant to be cheap. It's meant to be powerful. It's meant to be accurate. But just like anything else, as soon as you sort of simplify it, you lose some control and you lose some ability. But it's still very powerful, and it does everything I need. The other libraries, they're all, I'm not quite sure what they're doing. They're all trying to solve some sort of problem. I know that some of them are just wrappers for NLTK. They're just meant to make NLTK easier. In fact, spaCy does use NLTK for some things. So NLTK is inside spaCy somewhere. So yeah, some of those other libraries are there to make it easier for you too. I think spaCy is just maybe winning that race right now.
Well,
Another question?
go ahead.
Mm-hmm.
Yeah, you mentioned spaCy is fast and relatively easy to use, but you said it wasn't flexible. What are you losing by it not being flexible?
Well, I guess it's better to say less flexible, but I think because you're not specifying every detail of the modeling, it's actually a pipeline, right? So basically, spaCy is when we load this, I suppose it's more correct to say that it's not just an English model, right? There's an English model in there, but it's also a pipeline. So it's pre-processing the text. It's deciding on maybe lemmas or something like that. There's a piece of the pipeline that's the named entity recognition model that we use tonight to label these guys. So all of these pieces in the pipeline are set up for you in spaCy. You can go in and edit them. It's harder to get in. It's not hard, but it's not obvious how to get in there until you dig into the spaCy documentation. I mean, they allow you to get in there, but it's not just set up for you to jump right in and start editing. With NLTK, I think you're going to have to define that pipeline yourself. And while you're doing that, you're going to be making decisions that are specific to your project and to the best of your ability. spaCy is already making some of those decisions for you. So I mean, you can make changes. You can change that pipeline, but I just haven't had to yet. But I mean, you're asking, why is it less flexible? I think there's just less access to the things you can change. NLTK has that opened up, so you can actually get into those configuration options and so on.
So in terms of flexibility, you haven't run into a constraint yet. So it's not something that would immediately be a problem for anyone unless you're going to get really deep into the weeds.
Yeah, I would agree with that statement. Yeah, and I'm surprised. I think that I'm surprised at how well these models work on the documents I'm working on, because legal documentation, that's not the same English that we speak every day. It's not the same English we read in natural in our language naturally. I mean, this article is written in a more conversational English than a legal English. So I'm surprised at how well it works for my purpose, but it works well. And I've had to make some adjustments, like I've shown you tonight, and that improved it enough to work. So there is a company, I think they're called Lex Predict, LEXPREDICT, Lex Predict. They're either, I forget if they do consulting or what, but they actually open source their models, and it's for legal data, but I think it's legal data in the UK. So the legal language in the UK is different enough from in the US that I figured I wouldn't try it. So anyway, but I tried spaCy and I made some adjustments and it's working fine for me. So I didn't actually need to go down that road. But my understanding is that those models are available to use, and I would assume you can use them with NLTK and maybe also spaCy.
I think we have enough questions so far. Hang around. I'm going to stop the recording. But before we stop the recording, and please hang around after I stop the recording, we'll continue this meeting. I want you to all thank our speaker, Eric. And the way I'm going to do it is we're all going to unmute. I'm going to all unmute you, and we're all going to clap or shout or whatever until we get an echo, and then I'm going to close down, and and then we're going to continue. Just stay along, and I'm going to unmute you all now. So thank you, Eric.
Thank you.
Thanks.
Hey, thanks, Eric.
Thank you.
Thanks everyone for attending.
Awesome.
Thank
Yeah,
you.
no problem.
Very
Thanks for
good.
Thank
having us.
you.
Good questions.
Okay, I'm going to stop the recording now, and I'm going to upload it to YouTube later.